Alright folks, so the next step is to go ahead and set up the LEDs. Now I've got this device here. This is a solid state receiver controlled switch from Hobby King. It handles 10 amps at 30 volts, which is far more than I need. And what I'm going to do is I'm going to splice it in between either the positive or the negative wire from this 12 volt regulator, and then I'm going to go ahead and plug this into an extra channel on my receiver, which is going to allow me to turn the lights on and off. I've also got this set up for when the signal is lost, the lights will blink on and off. So with 40 watts of LEDs in the arms and another 40 watts on the gimbal, if I do go into failsafe, it's going to be incredibly obvious from long range. I mean, this thing will light up the sky like crazy. Even if I have the light switched off, it will go back into the blinking mode. So why don't I go ahead and get started, and I'll show you guys what I'm going to do. Now, this is totally not necessary if you're just doing a standard build, but I am completely ridiculous. So I'm going to put the LEDs on here, and I'll show you how that's done. Okay guys, so here's how this is wired in. We've got the PMU attached to our battery line auxiliary outputs. We've got our receiver switch wired in series to the voltage regulator. So remember that this is just going to act like a jumper to wire these two in parallel. When this switch is on, these two will be wired in parallel. We do not ever want to wire this in series, because it'll drop the voltage between those two, and this won't get the right amount of voltage to run, and neither will this. So that will be bad, and possibly fire starting. So the next thing that we're going to do is we're going to go ahead and solder the LEDs into place, their cables into place, all the positives to the positive side, all the negatives to the negative side, and then we're going to solder on a JST plug for the two LED drivers that we're going to have on board for the other 20 watt LEDs. Alright guys, so we need to design a new voltage regulator system for the LEDs on my copter, because the other one was a switching regulator that was big and heavy, and I accidentally lit it on fire. So a better way of doing this, I think, will be to take one of these Radio Shack 12 volt 1 amp voltage regulators. Now be really careful when you buy these, because they look exactly like transistors. They're built in the same case. And because I'm running 1200 milliamps of LEDs on 12 volts, the others will be on my 4-cell voltage. But for 12 volts, I'm running 1200 milliamps. What I can do, because these are linear regulators, is I can solder them in parallel and essentially get 12 volts at 2 amps out instead of just 1 amp. So let me show you how we're going to go ahead and do that, and I'll show you how to slap it in the copter. The total weight of each of these units is like nothing. I think they're like 1 or 2 grams a piece. They're very lightweight compared to 18 grams for the switching regulator. So let's get these soldered together. All right, before we continue, let's just kind of get a feel for the pin out here. Here on our single device, the pin on this side on the left, This is going to be your output voltage. So this is going to be the 12 volts regulated. The middle pin right here is going to be the ground, and the input pin here, this is going to be any voltage greater than 12 volts. So that'll be like my 4-cell pack voltage. Now what you're going to do is you're going to connect the positive from the 4-cell input to this pin. You're going to connect the negative of the 4-cell input to this pin. You're going to connect the positive of the LED to the output pin. You're going to connect the negative of the LED to the middle pin, the ground pin, because it's going to all act as a common negative. So that's why it has 3 pins. That's why it kind of looks weird. Instead of having, let's say, 4 pins, you could split that off into 2 pins, but it would be electrically connected. So just put all of your negative wires on the middle pin, your 14-volt wires on the right-hand pin, and your 12-volt positives on the left-hand pin. So let me go ahead and show you how to solder these in parallel. Alright, so you'll see here that I just CA'd them back to back so that the pins would line up. You know, it's not really rocket science. The intention here is to kind of tent the pins like this and then solder them all together the way that they should be. So all of the output pins, both the output pins should be soldered together, which will be there. The ground pins, which are in the middle, will be soldered together, and the input pins should be soldered together also. And this should share the load perfectly fine. Okay, so we'll just get to soldering that. Okay, excellent. So that's that. Now we need to solder in a cable for input, output, and ground. And I think that something good to use would definitely be like a servo cable, because it will be obvious which one is which connections are which. So take a little bit of a servo wire. You don't need the connectors, really, just the wire, because we're going to solder it in place. For input, I'm going to go ahead and use the signal wire from the servo cable, just so that we kind of have an idea of which is which. It doesn't matter which one you use. Whichever one you prefer is perfectly acceptable. This is just so that we remember which pin is which when we heat shrink this whole thing, so that there's no shorts. Okay, and then we'll go ahead and take our heat shrink and slide it up the pins there. And then take our hot air gun. Take our hot air gun and go ahead and shrink that tubing down. Okay, there's one pin. Now the middle pin is the ground pin. So we'll connect our negative wire here, the black wire, to the ground pin. Okay, slide that heat shrink up again. Make sure it's flush with the base of the device. Blast it with the heat gun there. Alright, last connection. This is going to be our regulated output. So this is going to be our 12 volt output here. Exactly the same process. Okay. Slide this all the way up the device. Okay. Just because I'm extra cautious, I'm going to use another piece of heat shrink to go all the way around on the outside. And there it is. There's the completed voltage regulator unit. It's really tiny. It only weighs a couple of grams and will handle 2 amps of maximum output current. So let me go ahead and show you how we're going to hook that up to the quad now. All right, everybody. The time has come to solder those LEDs into the voltage regulator. Now, the 3 things that we're going to be paying attention to right here are the positive and negative of the 14-volt input, the switch, the receiver switch here, the voltage regulator, the common negative of the LEDs that are all in parallel, and the common positive of the LEDs that are all in parallel. So we'll try and move some of this wire spaghetti around. Okay, now what we're going to need to do here is we're going to need to attach the common negatives here, and as well as the common negative of the voltage regulator. But before we do that, we do need to leave a little bit of extra cable to connect to the extra LEDs that I'm going to have on board, the 40-watt LEDs that are going to be on the gimbal. So what I'm going to do is I'm going to solder in a JST connector, and that JST connector is going to allow us to then connect the LEDs to later. That's how I think that we will be best served doing that, because I'm still waiting on one of the drivers, because I had a faulty driver and the manufacturer is getting me a new one. So at least I can get a working system that I can then just kind of plug and play the drivers into later. All right. So all the negatives, negative of the regulator, the negative of this and the negative of the LEDs, these are all gonna come together. Okay, so the negative end of everything is soldered into the common ground. Now, the input here for the 14-volt input is going to be the gray wire. Now, the other side that we have, the positive 14 volts, is going to be coming through this receiver switch. So what we're going to do is we're going to cut a channel and cut a piece off this wire, strip it, attach the receiver switch to the input of the voltage regulator and the positive lead of the JST plug, because you'll remember that the LED drivers that we're going to be using are good up to 24 volts, so they don't need to be on a regulator. So it's a waste of silicon and a waste of weight to have extra regulators protecting these circuits that don't really need the lower voltage, and we'll end up actually drawing more current that way and generating more heat. So we're going to solder these two guys right here like this. Okay, so if this is getting hard to follow, don't worry, you're not the only ones. Let's just go ahead and recap what's going on here and trace it out. So we have our 14 volt positive input, which is going to the receiver switch. When the receiver switch is activated, the current will flow to the JST, to ground for our white LEDs that are going to be on the gimbal, that are going to take upwards of 24 volts. And then it's going to flow to the input of our voltage regulators. And then that is going to, all of this is common grounded, including the LEDs on the frame here. And then the positive of our LEDs, our frame LEDs, is going to come over to the positive side of the voltage regulator. And this way it'll allow us to simultaneously run 12 volts to the LEDs that need 12 volts and 24 to the, or I'm sorry, 16 from the LiPo to the converter and driver circuit that will allow the large 20 watt LEDs to run on 24 to, I think, 30 volts is their range. Okay. Alright, so this should be all properly wired up. The only thing we can do now is plug it in and give it a test. Look at that. Pretty cool, huh? That's all good. That's all running. So that works fine. And these guys are getting a little warm, which is interesting. Guess we'll have to find some way to heat sink those. But other than that, that looks like it's all right. So if you like this video, guys, don't forget to rate, comment, subscribe so I can bring more to you, and we'll keep going with this build.